Whiteboard is visible to everyone?
Yes.
Okay. Okay, perfect. Good morning to all of you. Today we will start ionic equilibrium. So basically in ionic equilibrium, the main problem is correlating the things or correlating the compounds if given in the solution simultaneously. It is slightly difficult. So ionic equilibrium is the most easiest chapter if you are able to do all the calculations and everything. So, in this chapter, we will realize after the completion of this lecture that every problem of ionic equilibrium is related to one equation only. Means if buffer solution is given or salt is given, anything is given, everything is related to one equation only. So, this should be the feeling after this lecture, and you all will realize that yes, this is the based on only one equation. So in this chapter, there will be few sections. Like first section, a strong electrolyte aqueous solution can be given in the problem. A strong electrolyte. Now, a strong electrolyte can be a strong acid, can be a strong base. Yes or no? Second, weak electrolyte aqueous solution. In weak electrolyte, weak acid, weak base can be given. Third, salt aqueous solution. Now we can have seven type of salt in this category. Strong acid, strong base, weak acid, weak base, strong acid, weak base, weak acid, strong base. These are for monoprotic acid or monoacidic base. Plus, we can have amphoteric, we can have amphoteric salts, okay, as well as we can have like Na2A, Na3A type solutions. Okay, is this clear to everyone?
Yes.
Just I will correlate everything from the one equation. So just I am writing all the topics right now. Fourth, after salt we will have buffer solution, and buffer can be divided in three parts like acidic buffer, basic buffer, and neutral buffer or salt buffer. Okay, and in the last, KSP and solubility related problem. Okay, so this is the main content of this chapter. So basically, I divided into five parts. I am not interested in doing a lot of calculation and all. Just we have to be strong conceptually only. So I will talk about the concept only. So first, whenever you see the problem of ionic equilibrium, you just categorize in which category It is. So after reading question, we can easily identify that it is the problem of type 1 or type 2 or type 3 or type 4 or type 5. It is very easy. Okay. So for a strong acid solution, what we can, and separately in this, basically some basic information, we can say pure water related things. Yes or no? There are some concepts regarding pure water. You all must be knowing all the properties of water and all. So now we can discuss. So basically, there are six sections: pure water, strong acid, weak acid, salt, buffer, and KSP. Okay. Now, what we can conclude: pure water related problems. See, we will start from zero, because if you are facing difficulty in ionic equilibrium, then your basic concepts are not good. This is the main reason, and most of the student faces a lot of problem in ionic equilibrium because of misconception. So in pure water, what I will suggest you to remember, like H2O plus H2O, we all know it will produce S3O plus OH minus. Okay, is it okay to everyone?
Yes.
Now we can write K equilibrium of this reaction. Okay, so activity of H3O plus into activity of OH minus at equilibrium divided by H2O of activity of H2 into activity of H2. So this is the K equilibrium reaction. Okay. Now this H2 is acting as an acid, so we can write Ka. Now Ka is basically H plus into conjugate base divided by acid. Now in this we will not take solvent, because if this is an acid, then this is solvent. Now we can write Kb also, S3O into OH minus divided by H2O. Yes or no? So Ka and Kb of H2O are equal. We all know dissociation of water is negligible. Yes or no? So and the activities of both H2O will be constant. The concentration of H2O is 1000 by 18. So this is Kb, and this H2O is constant, this H2O is constant, this is constant, and this is constant. That's why I'm saying, because C minus C alpha will tend to C. Here C minus C alpha will tend to C. So basically these two parameters are constant. So we can multiply in this. So this will be constant, this will be constant, this will be constant, and another we can define Kw, that is ionic product of water, and this is also one of the constant. So in pure water, mostly we will use this equation, okay? Kw. So from here, what we can conclude, pH plus POH, you all must be knowing this equation, pKw, okay? And definitely it is an endothermic process, okay? It is an endothermic process, and delta H is positive. So on increasing temperature, equilibrium will increase, hence Ka will increase, hence Kb will increase, hence Kw will increase. Is it okay to everyone? Is it okay to everyone? Yes.
Yes.
Now H3O is equal to OH minus is equal to root Kw. because in water, equal amount of H3O plus and OH minus will be produced if pure water is given. Okay, because we are dealing with pure water only. And at 25 degrees centigrade, we all know Kw is equal to 10 to the power minus 14. So H plus will be equal to OH minus will be equal to 10 to the power minus 7. So pH is equal to POH is equal to 7 for pure water at 14 degrees centigrade, at 25 degrees centigrade. Is it okay to everyone? No. Let's say this is C minus C alpha at equilibrium, C minus C alpha, C alpha, and C alpha. Now, what we can conclude at equilibrium, H3O plus is equal to C alpha, and C is 1000 by 55 because this is uh, density of water is 1 gram per ml, so 1000 gram per liter, and 1000 by 18, 1000 by 18 mole per liter. So 55.55 is the C into alpha. This is given 10 to the power minus 7. So alpha will be 18 into 10 to the power minus 10. Alpha will be 1.8 into 10 to the power minus 9. Now you can visualize alpha is very small. If alpha is very small, then we can easily neglect C minus alpha. We can write C. Percentage alpha, we can multiply it by 100. So this number will be yes or no? Now, what will be the K of water? This number is 10 to the power minus 14, and this number is 1000 by 18 because it is negligibly dissociating. So C minus alpha again it will be equal to C, and C is 1000 by. So K and Kv will be equal to 18 into 10 to the power minus 17. Then Ka will be equal to Kv 1.8 into 10 to the power minus 16. Is it okay to everyone? Is there any doubt in your water related problem? So from this data, what we can conclude, H2 is a very weak acid as well as very weak base. Okay. So we calculated alpha, we calculated percentage alpha, we calculated K, Kv. But remember one thing, these data are coming at 25 degrees centigrade. In the given problem, if temperature is given 100 degrees centigrade, then Kw at 100 degrees centigrade definitely will be greater than 10 to the power minus 14. So let's say at 100 degrees centigrade, at 100 degrees centigrade, if Kw of water is given 10 to the power minus 12, then everything will be changed. Yes or no? Now the neutral pH will be 6. Kw is 10 to the power minus 12. Then definitely K will be changed. Kv will be changed. Alpha changed. Percentage alpha changed. H plus ion, OH minus ion, and neutral pH will be changed. Is it clear to everyone? Similarly, at 0 degree centigrade, Kw of water can be given, let's say 10 to the power minus 16. Then everything will be related to 10 to the power minus 16. Here it will be related to 10 to the power minus 12. But if nothing is specified in a problem of ionic equilibrium, then we will always consider that temperature is 25 degrees centigrade and solvent is water. So is there any doubt in this section? Is there any doubt?
No.
No, sir.
Okay, perfect. Now we will move to second section. Weak electrolyte Can I rough this or you not?
Sir, 1 minute.
Okay. Done, everybody?
Yes, sir.
Okay, perfect. Now, a strong acid, a strong base, aqueous solution. So, problem handling is very important. How I will proceed in the problem or what is my thought process, it is very important to you. Okay. So, you just, let's say we are given HCl aqueous solution, and we all know HCl is a strong acid, and this is given C molar. Okay. Now, how will I will proceed? You just see HCl is a strong acid. Okay, so when it will go in water, it will act as a strong electrolyte, and it will produce H3O plus Cl minus. Is it okay? Now T is equal to 0. The C molar is given, and water is always in excess. Initially, it will be 0. It will be 0, and T is equal to T completion. This will be 0, this will be in excess, and this will be C, this will be C. Is it okay to everyone? This is the definition of strong acid. Okay. If a strong acid is given in the water, then dissociation will be 100%. Okay. Is it okay to everyone?
Yes.
Okay. Now, I will mention here only one point. Sometimes JE may give you activity coefficient. Just remember this thing. If activity coefficient of HCl is given 0.5. If nothing is given, we will consider 1. Okay. If activity coefficient of HCl is 0.5, then basically its activity coefficient is 0.5. It should produce CH3O plus. Okay. So if activity coefficient is given, then it will be multiplied by, so basically H plus will be 0.5 into C, and Cl minus will be 0.5 into C. But if in the problem it is not given, then we will assume always 1. Is it okay to everyone?
Yes, sir.
Okay. So if in the given problem, if activity coefficient is 0.5, then H plus ion will be 0.5 into C. But in JE, in most of the question, because in up to class 12, this activity coefficient is not in syllabus. But JE may ask you, because they can define activity coefficient and they can create one problem. So you just be aware that what is activity coefficient. It will be multiplied by that activity coefficient. In reality, total activity will be activity coefficient into concentration. Okay. But if nothing is specified, then now there will be another equilibrium because water is there. If water is there, then nobody can stop to ionize this. Now this is weak electrolyte, and this will be an equilibrium reaction. I will write this equilibrium sign for weak electrolyte and irreversible sign for a strong electrolyte. Is this clear? No. Let's say this is solvent, this is an excess, and this is 1000 by 18. This is the normal. No, we don't need to solve the equation of a strong acid. Okay. Now, basically, what equilibrium we are having in this problem? You just identify the equilibrium reaction in the given problem. This is not a equilibrium reaction, okay? Equilibrium reaction is this only. But what is the difference in pure water and in this case? In this case, only H3O plus is given extra. Yes or no? The rest things are exactly same. So I am assuming this C1, okay? This is C1. Now initially, in pure water related problem, this H3O plus was 0. Yes or no? But here it will be C. Is it okay to everyone? So this is the main difference. Basically, we are converting this problem to pure water. The things are exactly same. Now, at equilibrium, C1 minus C1 alpha, or we can say C1 minus X. Okay? Here, C plus X, and this will be X. Perfect. Now, what we can write? Kw is total H3O plus at equilibrium, total OH minus at equilibrium, at equilibrium, okay? So C plus X into X will be Kw. Is there any doubt? No. Kw will be equal to Cx plus X square. X square plus Cx minus Kw is equal to 0. From here we can calculate X. X will be minus C plus minus root C square plus 4Kw divided by 2. No, the value of X cannot be negative. Yes or no? So we can discard one value and the final value will be okay. Now, final H3O plus. H3O plus will be C plus X. So we can put the value of this X. We will have C plus root C square plus 4Kw by 2. This will be your H3O plus. Okay. H3O plus total. Is there any doubt in this? No. OH minus total. OH minus total, definitely when we will have H plus total, then we can write Kw upon H3O plus total. Is this okay to everyone? Is there any doubt in this section?
Uh,
Okay. Okay, now listen. You must be remember one thing that this the H plus ion coming from a strong acid H plus ion coming from a strong acid is greater than 10 to the power minus 6, then total H plus will be equal to H plus coming from acid. You all must be knowing this fact. Yes or no?
Yes.
But because this is not the real case. See, in this equation, we don't have any approximation. Yes or no? So this is the real equation. Now, now listen carefully. This problem can be asked, simple problem can be asked in 0 degree centigrade. Okay. So at 0 degree centigrade, Kw will be 10 to the power minus 8, minus 16. Yes or no?
Yes.
So in front of 10 to the power minus, now see, we have to deal with this equation only. We can have multiple problem. We can have mixing, we can have acid, base, two bases, three bases, four bases. But all the problem of this section will be solved by this equation only. Now, what suppose if solvent is not given, we will assume water. Is it okay? Now they can change solvent also. Let's say they put HCl in the ammonia, okay? And they are saying, do not consider the reaction between HCl and ammonia, only consider the ionization part, okay? They can give you formic acid as a solvent. So this is the Kw. Kw can be different, okay? Now, what is the best part of this? Because all the problem will be solved by this equation only. This is the best part. You can ask me any problem related to in the solution in which final solution is having one strong electrolyte or a strong electrolyte in water or in any other salt. No. H plus total will be equal to C plus root C square plus 4 Kw by 2. Now we can have three cases. If C square is very greater than 4 kW. Then what will be H plus total? Yes or no? This will be approximately same. Is it okay to everyone?
Yes.
Second, we can have C square is very less than 4 kW. Yes or no? Then H plus total. Is it okay?
Yes.
And third, if both numbers are comparable, then we have to solve by this equation. You don't have any alternate. Yes or no?
Yes.
So I always use one term that ionic equilibrium is the game of numbers. See, in the same problem, it could have been C. It can be C plus 4 in the same problem by changing only number. Okay. Is this clear to everyone? Is there any doubt? And one more thing. I am saying C square is very greater than 4 kW. Then what is the reference point of this neglection? So you always assume 100 plus minus 5 can be written as 100 in ionic equilibrium. Is this clear? In front of 100, I can neglect to 5. Yes or no? In front of 100, I can always neglect to 5. So 100 plus minus 5. So I will say C square is very bigger number than 4 kW. You just take 5% of C square, okay? If if 4 kW is lesser than 5% of C square, then it will lie in this equation, in this category. Is this clear?
Yes.
Yes.
So here we will have definitely we must be knowing kW. So we will have 4 kW. We will have C square. Now we will calculate 5% of this number. If 5% of 4 kW is lesser than C square, then we can neglect C square in front of 4 kW. And if it is in like comparable value, so if it is not negligible value, then it will consider in this zone only. Is this clear?
Yes.
Okay. Now we can have multiple problem in this, and all the problem will be linked to this concept only. Okay. So I will solve one problem. You need to note down this concept. If you want to note this one. Once you all completed, please let me know. All of you done this one?
Yes.
Okay.
Yes.
Now you can note this one. Now solve this question. Calculate pH, H plus water, H plus total, H plus concentration acid, OH minus total, OH minus from water at 100 degrees centigrade. If Kw of H2 at 100 degrees centigrade is 10 to the power minus 12 in 10 to the power minus 5 molar HCl aqueous solution. Okay, so OH minus ion, water will be, because the source of OH minus ion is water only. So 10 to the power minus 7. Now H plus ion from water, because from water H plus ion is equal. And pH will be definitely 5, pOH will be 7. Is this clear to everyone? Is there any doubt? I will explain it one more time. See, after seeing the problem, it is understood that this is the problem of a strong electrolyte aqueous solution. So for a strong electrolyte aqueous solution, every problem, I will start from here because acid is given, so I will take H3O plus, okay? C plus root C square plus 4Kw by 2. And C is the concentration of HCl. Yes or no? So C is 10 to the power minus 5. Now Kw is given because we are talking at 100 degrees centigrade, then 100 degrees centigrade, Kw is 10 to the power minus 12 given. Okay. So we can easily calculate H plus ion total. Once we calculate H plus ion total, we can easily calculate OH minus total. And in this problem, the source of OH minus is only water. And in water, the ionization will be equal. If water will give XH plus, then it will produce XOH minus also. So OH minus total will be equal to OH minus from water, and H plus from water and OH minus from water will be equal. So see, now in reality, this number, in reality, H3O plus total, actually it is equal to 10 to the power minus 5 plus 10 to the power minus 7. Yes or no? Now we are neglecting 10 to the power minus 7 in front of 10 to the power minus 5 because this smaller number is 1% of bigger number. So we can approximate to 10 to the power minus 5. Is there any doubt in the problem? You all understood this
Yes.
problem? Okay. Now at a different temperature, the value can be different. Okay. If this value, if they are talking at 200 degrees centigrade, then if this value is given 10 to the power minus 10, then the things can be slightly different. You understood? Again and again, I am saying all the problems of a strong electrolyte will be solved by this equation only. Now, if a strong base is given, a strong base is given. Now, a strong base, let's say C molar NaOH aqueous solution, okay? C molar NaOH aqueous solution, then things will be same. OH minus total will be equal to C plus root C square plus 4Kw by 2. Is this clear to everyone? If a strong base is given, then equation will be same. Yes
Yes.
or no? Now H plus total. In this case, definitely Kw upon OH minus total. Yes or no? And in this problem, H plus total will be equal to OH minus from, oh, sorry, H plus total will be equal to H plus water, and H plus water will be equal to OH minus water. Yes or no? You can note this concept, strong base. Okay. Now, now we can have any problem and we will relate to this equation only. Okay. Now in this problem, 1 liter of 10 to the power minus 1 molar HCl aqueous solution plus 2 liter of 2 into 10 to the power minus 1 molar HNO3 aqueous solution and 3 liter of 10 to the power minus 5 molar HCl aqueous solution is present. Find the final pH, final H plus from water, H plus from acids, OH minus. Okay, so everything we can calculate in this problem. Now listen carefully. We are given H plus, okay, HCl. We are given HNO3 and we are given HCl. All three are strong acid. Is this clear?
Yes.
All three will furnish completely H plus. So the moles of, we can calculate moles of H plus coming from acid. Okay. What will be moles? Molarity into volume. So 1 into 10 to the power minus 1 plus 2 into 2 into 10 to the power minus 1. This will be for HNO3 plus 3 into 10 to the power minus 5. Is this okay? These are the total moles of H plus coming in the solution divided by total volume 1, 2, and 3. So this will be 6. This will be H plus coming from acid. Is this okay?
Yes.
Yes.
Now, now this is 10 to the power minus 1. This is 10 to the power minus 1. So this will be 5 into 10 to the power minus 1. This number is very small. Yes or no? So this will be 5 by 6 into 10 to the power minus 1 molar. And this is your C. Yes or no? And given all are strong acid. So this is the value of C. And if we want to calculate H3O plus total, then what formula we will use? C plus root C square plus 4KW by 2. Now you can say, sir, I don't think there is a requirement of to use this formula because we already know such type of problem. But if this data is given 10 to the power minus 7, if this is minus 7, this is minus 7, this is minus 7, then the importance of this formula, you all think about this. That so basically, yes, I will use this formula only, but I know the value of C, then it will be neglected for KW in this problem. Understood everything in first problem?
Yes.
Is there any doubt? So again, I am saying I am solving this problem from this equation only, from one equation only. Again, now a strong base is given, and again a strong base, and it will furnish twice of H plus. Yes or no? So what will be moles of OH minus, or we can calculate moles of concentration of OH minus. Here moles of OH 1 into 10 to the power minus 1 plus. It will furnish twice of calcium hydroxide. Yes or no? So 2 into 10 to the power minus 1. Is it okay? Now there will be no reaction between two bases, and total volume 1 and 2, 3 liter. Now again, this is C. Now, how we will calculate OH minus total? C plus root C square plus 4KW by 2. Understood?
Yes.
Again, HCl is given, NaOH is given. Now, acid-base reaction is the most fastest reaction in chemistry. So first we will react HCl and NaOH. It will produce NaCl plus H2O. Now T is equal to 0. What are the moles? 1 into 10 to the power minus 2 and 3 into 10 to the power minus 2. This is 0. This is 0 initially, and this will be 0. This will be 2 into 10 to the power minus 2. And NaCl is actually NaCl is inert. Yes or no? Because the hydrolysis of Na plus and Cl minus is not happening at all. So the final moles of NaOH at the end of reaction, 2 into 10 to the power minus 2, and concentration of OH minus 2 into 10 to the power minus 2 divided by 1 plus 3, that is 4. Understood? Now this is the value of C. So again, we can use this formula, OH minus total C plus root C square plus 4KW by 2. Is this okay?
Yes.
Now we can create multiple problems. Here, let's say I am saying minus 7, here minus 7, and here minus 10. Now the things will be different. Yes or no? So ionic equilibrium is the game of number. If you will change number, then solution will be changed. Yes or no? So now it is clear a strong acid or a strong base aqueous solution. Is there any specific doubt you can ask? Okay, now we will move to our third category. So basically, we completed two categories. First, pure water related problem. Second, strong acid related problem. Okay, now we will move to weak electrolyte related problem. Let's say weak acid aqueous solution. And this slide will be the game changer. Okay, all the buffer, all the salt, everything I will relate with this concept. What I said in the in the initially, I said that I will relate every problem of ionic equilibrium from one equation. That equation will be this one. Because a strong acid, in the case of a strong acid, there is no, actually in reality, there is no equilibrium. Yes or no? Because in a strong acid, it is completely dissociating. So the strong acid and pure water related problem already completed. Now the most important section is this. And I will give you minimum information. I will give you minimum information, and you can solve all the problems. You just see carefully. Let's say it is given HA, okay? HA plus water, and it is a weak acid, so it will produce H3O plus A minus. Is there any doubt in this? Because it is a weak acid, so it will be in equilibrium. Now T is equal to 0. Let's say C, water is in excess, 0 and 0. Is there any other equilibrium in this case? This equilibrium always exists, yes or no?
Yes.
If pani is given or water is given, this is always correct. Now, T minus C alpha, C alpha, C alpha. Now, what we can write K, C alpha into C alpha divided by C1 minus alpha. K will be equal to C alpha square 1 minus alpha. Now, K by C will be equal to alpha square divided by 1 minus alpha. Now, now it's very rare that you have to solve two simultaneous quadratics. Okay. See, we will use this equation in weak electrolyte, only this formula. Kw will be equal to H3O plus into OH minus. So this information will be used. Okay. And again, okay, so I will proceed this one, and I will explain about this after solving this section. Okay. So this is the weak acid simple equation. If we are given K, we are given C and K, we will be able to solve alpha, and we will solve C alpha. Okay. And finally, we will have H plus. Is this okay?
Yes.
No. Now we can have C is very, very greater than K. If C is very, very greater than K, then definitely K by C will be very small number. Then alpha square by 1 minus alpha should be very small. Is this okay? Now this can be very small. Then alpha square should be very small. Yes or no? Or 1 minus alpha is very bigger. Now 1 minus alpha cannot be very big. Yes or no? Yes or no? So there is only one condition, that alpha should be very small. Is this okay? If alpha is very small, we can write 1 minus alpha, we can approximate 1 minus alpha to 1. Now this equation will reduce to k by c will be equal to alpha square only. Yes or no? Now alpha will be equal to root k by c, and H3O plus will be c into alpha, c into root k by c. So finally H3O plus will be root c into k. Is there any doubt in this section? Just after seeing the value of c and k, we will proceed. If c is very, very greater than k, then we can proceed like this. Now, we can have another type. If ka is very, very greater than c. Now, k by c will be very big number. Then alpha square 1 minus alpha should be very big. Yes or no? Am I audible?
Yes.
Yes, sir.
Now, alpha square will be very big, or 1 minus alpha will be very small. Is this okay? No, this is not possible because the maximum value of alpha is 1. So alpha square cannot be very big. So 1 minus alpha, very small, it may tend to 0. So alpha will tend to 1. Here alpha will tend to 1. Then weak acid will behave like, weak acid will behave like strong acid, and H3O plus will be approximate to C only. Is this okay to everyone? Is this clear to everyone?
Yes.
Yes.
Now, if Ka and C are comparable, if both are comparable, then solve K by C is equal to alpha square. We cannot approximate. Find alpha and find H3O plus, that is Cl. So again, problem is one, but by changing number, we may have three cases. Is this clear? Now listen carefully about this section. In all these three categories, okay, category 1, category 2, category 3, we are not assuming the what H plus ion coming from water. Yes or no?
Yes.
So first we will calculate H3O plus in this way, okay? And H3O plus, and we know the, let's say we calculated, and let's say H3O plus is coming around 10 to the power minus 4, okay? In any case. If H3, if H3O plus coming from acid is coming out 10 to the power minus 4, then it is 100% sure that OH minus ion coming from, or OH minus ion total will be 10 to the power minus 8. Sorry, minus 10. Yes or no?
Yes.
And if OH minus ion total is 10 to the power minus 10, then definitely H plus ion coming from acid will be 10 to the power minus 10. Because OH minus total will be equal to OH minus water. and OH minus ion coming from water will be equal to OH minus ion coming from H plus ion coming from water. Yes or no? So what is my recommendation? First, you calculate H plus ion coming from acid only. Okay.
Yes.
Suppose if you are getting this number is 10 to the power minus 7. Listen carefully. You proceed in this way and you got H plus ion coming from acid. Okay. 10 to the power minus 7. Okay. Now, if H plus ion coming from acid is 10 to the power minus 7, now this number is close to H plus ion from water. Now, in this case, you will have to consider the contribution of water. But in normal cases, if your pH is 4, 5, 6, 1, 2, 3, or 13, 14, 15, or number can be anything. But if it is closer to neutral, let's say for what I always, if pH is coming, my pH is coming 6.5 to 7.5. Yes or no? If
Yes.
in any problem pH is coming 6.5 to 7.5 from acid or base, then this acid or base is close to water. Yes or no? Then only I will think about contribution of water. Otherwise, we will use this equation only for this. Okay? You got my point? What I am trying to explain you?
Yes.
Okay. So you can calculate in this way, you will find H plus. If that H plus is comparable to water, then only you can calculate easily. Now we are having this formula C plus root C square plus 4KW. Yes or no? Divided by 2. Yes or no? We can use this one. Suppose we are getting C, we are getting final H plus in the solution from this equation. So finally, for rough calculation, we can use this formula. Ideally, technically, this is incorrect way, but roughly we can calculate. Yes or no? Or it is simple way. If you don't want to use this formula, you just assume 10 to the power minus 7. Okay. So you can get an approximate idea of total H plus ion in the solution. So, but definitely it will be lesser than 10 to the power minus 7. So it will be better if you can use C plus root C square plus 4KW by 2. Otherwise, you can have plus X and in OH minus X, you can multiply and you can calculate. So is there any doubt in this section? You just note down this section. Done this part? Completed? Hello. Hello.
Yes, sir.
Okay. Now these can be simple problem on this section. 10 to the power minus 3 molar HA aqueous solution and K is 10 to the power minus 5. 10 to the power minus 3 molar HB aqueous solution if Ka is 10 to the power minus 3. 10 to the power minus 5 molar HC aqueous solution if Ka of HC 10 to. So very simple. We are not required to solve and we don't need paper and pen for this type of problem. Just see, it is a weak acid. Is there any doubt that HA is a weak acid because K is given 10 to the power minus 5? So the product divided by reactant ratio is 10 to the power minus 5. Yes or no? So it is weak acid. Now in this problem, C is 10 to the power minus 3 and Ka is 10 to the power minus 5. We can say C is very, very greater than K. Then H plus ion will be root C into K. Yes or no? 10 to the power minus 3 into 10 to the power minus 5. This will be 10 to the power minus 4. Now again, we can easily neglect contribution of water. Yes or no? pH will be 4. Now in second problem, C is comparable to Kv. K, because C is 10 to the power minus 3, K A 10 to the power minus 3. Now K by C is alpha square divided by 1 minus alpha, that is 1. So alpha we will have 0.59 after solving this quadratic. We can approximate to 0.6. Yes or no? So S3O plus will be C alpha 0.6 into 10 to the power minus 3. So 6 into 10 to the power minus 4. Is this okay to everyone? Now Ka is very, very greater than C. So S3O plus will be C only. 10 to the power minus 5. So pH will be 5. You understood this one? Is there any doubt?
No.
Okay. Now for a strong base, sorry, weak base. Weak base aqueous solution, let's say C molar AOH. Aqueous solution is given. Yes or no? And Kv of AOH is also given. So again, OH minus ion will be root into C into Kv, correct? And OH minus ion will be C into alpha. And OH minus ion will be C. Yes or no? For this, C should be very, very greater than Kv. For this, Kv should be very, very greater than C. For this, Kv should be comparable to C. Is this okay?
Yes.
Is this okay? Is this clear to everyone? If weak base is given, then we can have three possibilities for the calculation of OH minus. Is this clear?
Yes.
Yes.
Okay. Now You all solve this problem. Solve this problem. See, in the solution, there are two weak acids. One weak acid is Ha, another weak acid is Hb. So in one solution, Ha and Hb both are present. The concentration of Ha is 10 to the power minus 5 and concentration of Hb is 10 to the power minus 6. And Ka, both Ka for Ha and Ka for Hb is given. Find the pH of aqueous solution. This is very beautiful problem. You just solve and answer. Message me your answer. See, it is a mixing of Ha and Hb. Both are weak acid, okay? Both Ka are given, both concentration of both acids are given. And if H plus ion total is root x into 10 to the power minus 14, then we have to calculate the value of x. You all can answer quickly, one by one. Sandeep, you are getting 3. Could you please explain this?
So we see that if we consider only acid A and acid B ionizing, then we write K is H plus total into A minus upon HA, and Ka dash is H plus times B minus upon HB. And if we consider only these two to dissociate, then A minus plus B minus is H total. So in that case, we get pH something close to 7. So we consider ionization of water as well. Then we get A minus ion plus B minus ion plus OH minus ion concentration is H plus total
Perfect. So
concentration.
you are using charge and mass balance.
Yes.
Okay, okay, perfect. And so you are also getting 3.
Yes.
So do you have different explanation?
No, sir, I agree with Sandeep. Like conservation of charge, you can't neglect KW.
Okay, okay, perfect. So you both please send your solution in the group, okay? After the class.
Okay.
So I want the solution of this question from everybody, okay? Just I am correlating this thing with one of the very famous formula, okay? You all must be knowing this thing, I guess. You all are aware with this formula?
Yes.
And for this formula, the condition is C1 should be very, very greater than K1 and C2 should be very, very greater than K2. Then we find this formula if we are having more than one weak acid in the solution. Okay. Is this okay?
Yes.
Now, C1 is very, very greater than K. If C and K, C is very, very greater than K, then its alpha will be negligible. And here also C is very, very greater than K. Again, its alpha is negligible. So if we are having two acids, then normally students are aware with this formula, okay? And there are two acids, they will add this and they will get the value of X2, okay? Because this is 10 to the power minus 14, this is 10 to the power minus 14. So we will have 2 into 10 to the power minus 14. But there is one more thing need to remember. One more thing need to remember that water is also here as will act as acid because number is comparable. Because root c into k for this 10 to the power minus 7, root c into k for this 10 to the power minus 7. Okay, so here basically there are three acids. So we will do like this: C1K1 plus C2K2 plus C3K3 of water. Yes or no? Because basically we are having three. This is for HV, this is for HA. So what we will have 10 to the power minus 14, 10 to the power minus 14. And C into K of water is nothing, it is KW. Is this okay? Is this okay to everyone?
Yes.
So if you want to use this formula, then you can use this also. But always remember if these numbers are comparable to KW, then you will have to add you have to add the contribution of water also and the contribution or KW like C into Ka of water is KW because we know this H3O plus into OH minus divided by C. It was Ka. Yes or no? So C into Ka will be KW. Is this okay to everyone? So I want the solution of this question from everybody. You just send me your solution. If your approach is from this, then I need solution. I need derivation of this part. Okay. If you are using this formula, then you will have to send me the derivation of this part. And if you are solving from charge and mass balance, then derivation is not required. Okay, so today we will stop here. I will send you few questions. So you just solve and send me. Okay, thank you.
Thank you, sir.